In this example, we will anti-differentiate the rational function given here. Now, the observation to make is that it is a quadratic over a cubic, so it is a proper rational function. So the first step towards evaluating would be to write out the form of the partial fraction decomposition. So to begin, let's go ahead and just factor the denominator. Each term has an x present, so if we pull that out, we're left with 3x squared plus 4x minus 4. And this resulting quadratic also factors nicely. So looking at what we have, the 3x squared plus 4x minus 4, you might think of this as, 3x and an x. And to fill this out properly, to get the 4x minus 4 remaining, we're going to need a minus 2 and a plus 2. So the denominator factors very nicely into 3 linear terms. So the form of our partial fraction decomposition is going to be a over x plus b over x plus 2 plus c over 3x minus 2. And in order to solve for the a, b, and the c, our first step is to take the denominator on the left and multiply both sides by it. So in the first term, the x's will cancel. We'll have a times 3x minus 2 times x plus 2. In the middle term, the x plus 2's cancel, so we have b times x times 3x minus 2. And in the third term, the 3x minus 2's cancel, so we have x times x plus 2. And since we have all linear terms present, we actually don't have to expand this entire expression on the right. We can simply plug in 3 intelligent choices to solve for those corresponding constants. To solve for a, we plug in x equals 0. So if x is equal to 0, on the left-hand side we have 4, and on the right-hand side we are left with a times minus 4. So in this case, a is equal to minus 1. To solve for b, we plug in x equals minus 2. When x is equal to minus 2, on the left we're going to have 8, and on the right-hand side we're going to have b multiplied by minus 2 times minus 8. So that would be b times 16. So b is equal to 1/2. And lastly, to solve for c, we're going to plug in the number x equals 2/3. And the reason I'm picking 2/3 is if you plug 2/3 in, it makes the a term and the b term vanish. So when we plug in x equals 2/3, on the left we're going to have 4/9 plus 4, and on the right we're going to have c times 2/3 plus the quantity, multiplied by the quantity, 8/3. And this is equivalent to telling us that c is equal to 5/2. So now that we've solved for our constants a, b, and c, we are now ready to anti-differentiate. So I've just carried over our work from the previous slide, and now in order to anti-differentiate, we're going to break it up into 3 separate integrals. So we're going to have the integral of minus 1 over x, plus the antiderivative of 1/2 over x plus 2, plus the antiderivative of 5/2 over 3x minus 2. The first antiderivative is going to be minus the natural log of the absolute value of x. The second, we have the 1/2 that pulls out, the natural log absolute value of x plus 2. And the third, we have the 5/2 that pulls out. And then when you integrate 1 over 3x minus 2, this is another one where you can just write down for me what it is, or if you're not seeing it immediately, you can use a u substitution. And the u you would use is 3x minus 2, so that du is 3 dx. And what this results in is an extra 1/3 that pulls out front, times the natural log of the absolute value 3x minus 2.